Hello everyone, I am Vinit Sharma and today I will be explaining the concept of analytical functions in SQL using the project that I have built called as Prison Building Contract. This project consists of two entities, namely builder and prison, and these are the attributes within these entities. These entities are connected with the help of a key called as builder ID, which serves as a primary key in builder table and foreign key in prison table. Prison table has its own primary key named as prison ID. Today we will be focusing on prison table, where we will be focusing particularly on attributes like prison ID, the opening date of prison, the capacity of prisoners the prison can hold, and the actual cost required to construct this prison. So let's get started. This is the problem statement we will try to solve in this video. We'll try to solve this problem using both traditional approach and analytic function approach. And we will convey our point on how analytic function can be helpful to solve these complex problems. The first four attributes to be displayed are same as I have mentioned previously. We will require two more attributes to be displayed, which will be sum of inmates that can be accommodated by newly opened prisons and sum of actual cost required to build those prisons which are opened in 1 year prior range of the prison we are looking at. What does this problem statement mean? So if we look at this example data set that I have prepared here, look at this date, 22nd October 2012. What would be the previous year capacity and previous year cost for this particular date? It will be uh, it will be a sum of capacity and sum of cost of prisons open between date ranging from 22nd October 2011 to 22nd October 2012. If we see this dataset carefully, these three rows fall in between those range. So previous year capacity will be a sum of these three rows, that will be equal to 45, and previous year cost will be a sum of these three rows, which will be 300 in this case. This kind of output we will be expecting from our code, from our query. So we also going ahead, we also have to filter the data on basis of opening date. We only require those prisons which are opened on or after January 2014, and we will also have to sort the data by the date opened. We'll go through this problem step by step to understand it clearly. Firstly, we will check all the attributes that are already mentioned in our dataset, and so that we can get a gist of data that we are working with. Then we will filter out the data based on opening date, and we will only take the data of prisons that are opened after 1st of Jan 2014. Moving forward, if we use traditional approach, we would have to use summary queries as correlated subqueries. This is the query that we get if we solve this problem by using a traditional approach. We will get two of some summarizing queries that are highlighted here in different colors. We will have to use aggregating function like sum, as we require sum of prison capacity and actual cost, and we will the both of the summarizing queries will have the same where condition, as we require summarized value of prison capacity and actual cost based on same range of date opened, that is 1 year prior to the date opened of prison that we are looking at. The same problem here is solved using analytic function, and the straight away difference that you can see here, the summarizing query that we have used, the result that we have gotten using three lines of summarizing query is solved using one line of analytic function. It makes our code minimalistic and simple than that of traditional method. Now the first question will be how we will be differentiating between aggregating function like sum and analytical function. This can be an aggregating function too. So the answer is, whenever an aggregating function like sum is used along with over clause, SQL understands that it is not an aggregating function, it is an analytic function. So how is the structure of these analytic functions? Firstly, we specify the aggregating part of our query. Then we specify the over clause. Over clause can consist of different analytic clause, namely partition clause, order by clause, and windowing clause. In this example, we have not used partition clause as it is not required. But here you can see the order by clause where we have mentioned that we need our data sorted by date open, and the range 365 preceding is a type of windowing clause which is the backbone of this particular problem, as we need to specify uh, of what range of data we require. Here we require the data of range 365 days prior than date open, which is what specified here. Range is 365 days and preceding means before, and which is the attribute it will apply the range on. It will be the one we have used for order by, that is date open. So similar kind of query we can use to find out data related to range that is after the date open, 365 days after the date open. Just we need to change one word. This word preceding would be changed by following. This is the minor difference that can make major differences in output. Now let's see the result of this query. So this is how we get our output using analytic functions. The output is as we have desired. We can cross check it by using by checking one of the records. Taking this one for example, the prison has opened on 17th of May 2021. So it will want the sum of capacity of prisons opened between 17th of May 2020 and 2021. As we can see from the records, these three rows fall into that range. So if you will calculate, sum of these three values will be equal to 894. So we can also see that our query is working accurately. So this is how analytic function is can be used to solve this kind of complex problem and make our life a little bit simpler. Thank you.